Ladies and gentlemen, honored veterans, and my friends in uniform from all three services. Many of you in blues I know have much more know about space and have been closer to it, as the chair mentioned, flying there. I, of course, from ground, give you a perspective of what is there in space, where is it moving ahead, and what are we planning in India. I start my talk with a study which was carried by the US Air Force Space Command in March 2019, where they looked at the future space in 2060 and its implications for US strategy. It was for US strategy, but many of the things what the environment describes are relevant to all because US does lead in space. And what this study did was it looked at what would be the human presence in space, what would be the commercial aspect of it, and what would be the leadership role of US. It also looked at technology, where does it reach in these next 40 years, as well as what are the military implications. I'm just giving a snapshot of this to you because this sets the environment of what is likely to happen in the future. They had taken out 8 possible contingencies, but what they have done is in each these three domains of human presence, leadership, and commercialization, they've laid the lower bound and the upper bound. Lower bound that nothing much happens, and upper bound is everything which is imagined happens. Now, this talk and this discussions which took place when this report was taken out were done by the Department of Defense, NASA, the academia, the new space which is there in US, and of course the newly formed US Space Force. Just to give you a perspective of this, from the first slide, while at the lowest end, it is talked of that there will not be much of a development beyond the space station. And humans may go to the moon and Mars, but they may not be permanent presence. In the upper 2060, it is envisaged that there will be thousands of individuals from nations working in the low Earth orbit across the cislunar, Moon, Mars regions. There will be crude habitats across the whole cislunar space, supporting the overall logistics for space, manufacturing, tourism, and resource extraction. There would be habitats in Moon, Mars, and in the space. Now, in such a human presence, what is the commercial angle of it? At the lower bound, of course, they say the economy, it will contribute only 1 to 2% to the whole world economies. But in the upper bound, it is envisaged that about 10% of the gross domestic product of the world would be from space. There will be major industrial capacity for power, for resource extraction, and for manufacturing, which will be there in space. And space tourism as a major industry will be available to a wide cross section of the public. In both the scenarios, this is quite a US viewpoint at leadership, where in one of them they say that the leadership may be taken over by somebody else other than US, and in the other contingency that the leadership will continue with US along with the nations which look at space as a free domain. In both these contingencies, I'll skip over the political assumptions. I'll come to the defense assumptions. And here I would like to highlight that what is envisaged is that the conflicts will increasingly be integrated across air, land, sea, cyber, and space domains. And they would extend globally and also across into the cislunar space. And one very important assessment which has been made is the technical advantages between major powers would have narrowed or disappeared. And hence, success would be driven more by resources, logistics, and successful alliances rather than by a technological advantage. In this whole space, where would technology go? And this is of most interest to us. Already, with disruptive technology and AI, reusable rockets have become possible. Per kg weight to be sent to space is becoming cheaper every day. Miniaturization is ensuring that smaller satellites are able to deliver much more in terms of communication, in terms of remote sensing, and all the domains. What I have marked here in white is what is nearly has happened, and in yellow is what is envisaged and what may happen in the future, where there would be factories running in space for power, for extraction, and other domains. A little bit on the higher side, but a possibility which is there in the next 40 years. And if this is the technology and other aspects, with all contingencies of the minimum and the maximum, these realities stay. That is ISR and Earth observation. And today ISR and Earth observation is not only being used by the defense forces, but more and more is being used in the commerce sector. If you would go to the internet today and see Maxar's satellite pictures, you can count the number of tanks, vehicles, and persons which are deployed across Ukraine in Russia. This is available in the open domain with a resolution which is less than 30 centimeters, which is the accuracy of 1 to 4 meters. Apart from the use of defense, it is now being used in many domains in the civil. And that is where we have to be aware that today space has totally opened up. The visibility of the adversary and yours is totally very high. And the other issue is precision, positioning, navigation, and timing have become critical for everyone. Today, every common user in the street is using a GPS. And we in India have also been able to establish our IRNSS, which is by technology more efficient for the Indian subcontinent. Communications, of course, and what will be more important is if we would require emplacements and protection for critical space assets in space, which presently we don't have. Now, coming to the Indian space environment, now here I lay down what would be the aspirations of our armed forces. Traditionally, they have been in the domains of communication, Earth observation, recce and surveillance, and meteorology and PNT. But what we require now is launch on demands, a total maritime domain awareness, assets for space situational and domain awareness, and also assets for protection of our space assets. And they have to be both kinetic and non-kinetic. The Indian space environment presently has been purely led by ISRO. It has evolved from sounding rockets of the 60s to missions to Moon and Mars, which has been a significant achievement by ISRO in the last 60 years. The sanctions which were imposed to us, especially after our nuclear tests, have built-in self-reliance. In fact, one of the most happy part of the story is that ISRO could create vendors in India who were able to produce most of the components which are required in space. Our vendors today produce assemblies and components and are all set to do end-to-end space missions. The focus of ISRO was primarily on the common man, and overtly it dissociated itself from the military needs. That was the narrative for a very long time. It did try some commercialization with certain hiccups which took place, which you are well aware of. Now, the new trigger of privatization of space has taken place primarily because One, it is a global trend, and 15 years back, Elon Musk and others in USA have brought in disruptive technology with reusable rockets, which are now there. Going with this trend, international trend, along with seeing that ISRO today has a very large spectrum of activities from providing transponders to going to the Mars. There was a need that private players had to be brought inside. And also, the global space economy, which is by the last economic survey about $474 billion, we just have 2.6% of it. Though being the one of the six spacefaring nations, we are far below in our economic pie of this. And hence it was thought that there was an opportunity for space to be opened to the private sector. And maybe it would be an opportunity for the nation like IT and pharma. And of course, there is availability of talent pool in India, young men trained and ready to go. I'll mention about them later as I go ahead. Certain structures which have been created in India are certain enabling organizations, some regulations which are now on the way and which are coming. There is a creation of ecosystem and they're looking at making some space parks. What is most important is assured demand to the private sector if they have to go forward. And most importantly, finances, because the returns on any investment take a lot of time and are risky in the space domain. Out of the four structures which have come in India is in space, which will be regulating, authorizing, and monitoring private space. Dr. Goenka, an industrialist, has been earmarked to head it, and we are waiting for the first few policies to come out. A new space industries limited has been opened, which will primarily be a public sector company with all the ISRO know-how with them. ISPA was created basically to assist the private players to come into the space domain. And of course, the first step had been taken by the armed forces 2 to 3 years earlier by creation of the Defense Space Agency, which is led by an Air Force officer. And we hope it becomes the Defense Space Command sometime in the future. I would not go as to what all are the tasks of in space, but this would be the one which would be looking at the technical, legal, security, and monitoring all issues of space launch by private players. We at ISPA, our focus area is to be a united voice of the entire space industry and to ensure we are able to carry out capacity building in India. These are the regulations and policies which are coming. And most important out of these is the SATCOM policy, the remote sensing policy, and the FDI policy and the transfer of technology policy combined is coming, will be promulgated by the government in the next 1 to 2 months. While the space activity bill also by the middle of the year or by the end of the year is going to come. This is going to open the entire space domain to the private enterprise. What is there in the private enterprise today? I have flashed it here for you. Most of you would be knowing who are the present players who are available there. HAL and Bell lead from the public sector, while L&T, Walchand, Godrej, Alpha Designs, Anand Technologies, and Bhatt. All these people have been first-tier vendors for ISRO for years. They've been producing assemblies and sub-assemblies and are confident enough to carry out end-to-end products. We also have one BEV, which is owned partially by India, by Bharti Airtel, which is has already launched more than 300 satellites into the LEO orbit for communication. And this constellation would be ready as per them by the middle of this year. And once they get licensed into India, low Earth orbit satellites will be providing communication, broadband to remote parts of India. Interestingly, we have these startups. We have a total of 348 startups, but the first 10 are what I have flashed for you in front of you. And in world over, in 2021, the figures taken out, the number of space tech companies in India are the fourth largest. You could see that in the slide. We have 368, even more than China and France. What is available in the immediate future in India in the private sector is, firstly, like I mentioned, OneWeb will be able to provide low Earth orbit communication, which would be ready by the end of the year. Then there are companies. There is one company called Pixel, which is planning to launch 36 satellites for Earth observation, a constellation of satellites. Their first two satellites are ready for launch, and they would be providing this Earth observation satellites with hyperspectral images for the entire world. There are two other startups, Agniban and Skyroot, which are looking at 3D rocket engines, which will bring down the cost of launch vehicles much lower. There's another company working for green energy and creating electric propulsion systems. All these, what I'm mentioning, are either being space tried or have gone beyond their prototypes. And there's one small company of young people who have gone into space debris detection, and they would be launching microsatellites for providing, as they say, a GPS in space. All these are small startups operating in Bangalore, and after the policy takes off, this is what the future opportunity is there. And all these technologies can also, of course, be used by the armed forces. What are the challenges? The biggest challenge is the change management. For 60 years, there has been only ISRO. They've done an excellent job of it. But now, to give space to the private sector, to provide their opportunities, requires leadership, requires structures, requires a plan and a methodology to do it. ISRO has to be a facilitator and mentor for next 10 years for this new private space to develop in India. And of course, financial investments, both from private and government, are required. What is available today is, one is, we are very confident of the collaborative partnerships which will come. And secondly is the government's decision to be a strong enabler to take it forward. Just to give you a picture of in 2018, what was the military spending and where we were compared to the other nations. We are nearly fourth and do spend a large amount of money, budget for space. The later president of America in 1957, when he was a member of the US Senate, one of the committees had mentioned this, and of course, it is true for the future. I've finished here, and I'll take on my questions after the chair permits me.